Okay, so let's look at practice test 2, number 6. It says find the general solution. So you got y double prime minus 4y prime plus 4y equal to 9x e to the 5x plus 6 e to the 5x plus 12x minus 8. So we could use either the method of undetermined coefficients or the annihilator approach. I'm going to use the annihilator approach for this question, but you could use the method of undetermined coefficients also. So first, let's note. So we're going to note that looking at the left side here, y double prime minus 4y prime plus 4y. In place of y double prime, you can write d squared. There should be d squared y, sorry. D squared y. And then in place of y prime, you can write dy. And then this is a quadratic, and so you can factor out the y, and it's a quadratic. So factoring it, we get then. So we get then. So first I pull out the y, so it'll be d squared minus 4d plus 4, and this factors as d. You can check d minus 2 squared times y. Okay, so next. Okay, so we can replace now on this left side here, we can replace it with d minus 2 squared times y, which I've done here, equals right hand side still. Okay, now let's recall from question 5, we have, so from number 5 on the practice test, we have that this guy, linear differential operator, d minus 5 squared d squared, annihilates the right hand side, so annihilates this guy here. So let's multiply both sides now by our annihilator. So doing that, we get then. Okay, so we're going to multiply both sides by our annihilator from question 5. So doing that, we'll have our d minus 5 squared times d squared times d minus 2 squared y equals d minus 5 squared d squared times right hand side. But from question 5, this annihilates this guy, so it equals 0. So now we can find the form of our y. So our y here is going to be a solution of our differential equation. So we know it gets so our solution of our differential equation gets annihilated by this guy over here. So let's write out the general solution then for our y. So doing that. Okay, so we're looking for the most general function that gets annihilated by this annihilator here. So the d minus 5 squared, that will annihilate things of the form e to the 5x and x times e to the 5x. So it'll be, and this will be the most general form here, c1 plus c2x e to the 5x. This guy here would be annihilated by d minus 5 squared. Now the d squared will eliminate a constant, and will eliminate a constant times x. So my d squared would eliminate this whole thing here. And my d minus 2 squared guy, that would eliminate e to the 2x and x times e to the 2x. So in general, it would eliminate, say, c5 plus c6x e to the 2x. So this guy here would be annihilated by the d minus 2 squared. And this part here will be the homogeneous part, because it was over here when I simplify the left hand side of differential equation, I got d minus 2 squared. So that's going to generate our homogeneous solution. So this will be the homogeneous part. So this part here then will be the yp part. We'll find conditions on the c1, c2, c3, and c4. So let me write that here. So this part would be the yp, so yp would be then c1 plus c2x e to the 5x plus c3x plus c4. We're going to have to find conditions on these c1, c2, c3, and c4 that make this work. Okay, so you can see this annihilator approach is kind of nice because we didn't have to guess like the method of undetermined coefficients. You had to guess the form of your yp. Here we just got it from our analysis. So we know our yp will look like this. So now let's find conditions on the c's that make it satisfy our differential equation up here. So I'm out of space, so let me erase a few things and we'll keep going. Okay, so here's a yp. So we're going to plug into a differential equation up here. So let's find yp prime first. To do that, we're going to have to use a product rule on this first one, where the c1 plus c2x would be first function, the e to the 5x would be second function. So we do it down here. So doing that, we get then, so we get this, we get a, so derivative of the inside, the c1 plus c2x, with respect to actually just be c2, it'll be times my e, and plus my, this guy here, c1 plus c2x times derivative of my e function, will be itself times derivative of 5x will be 5, so it'll be 5 e to the 5x. Derivative of c3x would just be c3, derivative of c4 would be 0. Let me then factor the e out of these two guys here. So doing that, we get then, okay, so factoring the e out here, then it'll be c2, 5c1, 5c2x, which I've written here, plus c3. Now let's take second derivative, so we're going to have to use the product rule on this again. So my y p double prime will be then, okay, so y p double prime, so product rule on this, so derivative of this guy would just be 5c2, that'd be times my e to the 5x, then this guy, written here, derivative of the e would be itself times derivative of 5x would be 5, derivative of c3 would be gone. Then let's pull the e out here and combine things, so doing that we get then, okay, so pulling the e out, we'll have then 5c2, another 5c2 here, so 10c2, then we'll have 25c1, 25c2x, then all times e to the 5x. Now let's plug into differential equation and force conditions on the c's to make it a solution. So doing that, we get then, okay, so let's plug into left hand side of differential equation here. So we'll have our yp double prime minus 4yp prime plus 4yp. So using our yp double prime as this guy here, using our yp prime as this one, and our yp as this. So plug in, we get this over here. Then we'll combine the c2s. We got 10 c2s here, negative 4 c2 here. So it's like we're going to have 6 c2s. And then we have a 25 c1 here, and a negative 20 c1 here, so that'd be 5. And we got 4 here, so that'd be 9 c1. And then here we have 25 c2x, and a negative 20 c2x, so that'd be 5, and then 4, so it looks like 9 c2x also. Then the c3 here, we have negative 4 c3, and we'll have 4 c3x and 4 c4, so let me write that here. Okay, so combining the terms, we got a 6c2, 9c1, 9c2x. That'll be the coefficient in front of the e to the 5x. Then we'll have a 4c3x, and then we'll have a 4c4 minus c3, just combining stuff up here. That has to equal the right-hand side of differential equation, so equals right-hand side. Right-hand side, I can pull an e out and write it as 6 plus 9x e to the 5x plus 12x minus 8. Now we can start equating coefficients, so doing that. Okay, so equating the coefficients then, so the 6c2 plus 9c1 must correspond to the 6 over here, so that'll be my first equation. Then the 9c2x, that's the coefficient in front of the x over here, so the 9 then would have to correspond to the 9c2. That's my second equation. Then the 4c3 guy would have to correspond to the coefficient in front of the x over here, so 12. And the 4c4 minus c3 would have to correspond to the minus 8. So it looks like this one, solving it, c2 would be 1. Looks like solving this, c2 would be 3 for this one. Okay, so let's note that. Okay, so solving dividing by 9 here, c2 would be 1, dividing by 4 here, c3 would be 3. Okay, so I'm out of space here, so let me erase a few things and we'll keep going. Okay, so here's our system up here. So we found that c2 was 1 and c3 was 3, so putting the c3 over here And solving this, I'll let you check. You get C4 is 5. Okay. Is 1. Okay, and then putting C2 being 1 over here, then looks like C1 is going to be 0. Okay, now we can write our YP out here. So we have then, so our YP was C1 plus C2x e to the 5x C3x plus C4. So our C1 is 0, our C2 is 1, our C3 is 3, and our C4 is 1. So this would be our solution here. I guess you can take away that 0 there and just write it as x e to the 5x plus 3x plus 1. Now we can write the general solution. So let me write it here. So it follows then our general solution will be our YP, which is right here, x e to the 5x 3x plus 1, plus the homogeneous part, which we've already said. I call it C5 e to 2x plus C6 x e to 2x a while ago, but I'm just going to call it A and B here, just make it look nicer. Where A and B are just some any constants here at all. So this will be our general solution of the original differential equation. Okay, so we're done, so let's leave it there.